Hello class, this is Marcella, and for this lecture we're going to be continuing talking about thinning. And this photo on our front page, or on the first page of this lecture, is a growing stock study that the Forest Service is looking at how removing different densities in red pine influences growth and also resistance and resilience to a changing climate. So thinning. Thinning is a cultural treatment made to reduce stand density of trees primarily to improve growth, enhance forest health, or recover potential mortality. We are tending the stand. So this should be very familiar. This is pretty much straight from our last lecture. So thinning is a way that we tend a stand. And again, from our last lecture, we see that thinning can vary based on both how heavy it is, so a lighter thinning versus a heavier thinning, and the impacts it subsequently has on overstory, the overstory stand, including the crown, the diameter, the height. So thinning really can impact a lot of these structural elements of a stand. So we talked about, in the previous lecture, a lot about how thinning impacts an individual, how it can impact the stand. Today we're going to talk about how to actually implement it, so which to thin. So in that previous example, all the trees were the same. So that's generally not the norm. And we do see differences, just like in this picture below. We see that we're going to assume this is an even age stand. It's a single species stand. So why are we seeing differences? So why is this tree smaller than this tree? So a few reasons might be due to site and genetics. We also can see there may also be a difference in density. So in the previous lecture, we saw that density can have a huge influence on how trees form, so how they grow, what impact they have on them. So density, as well as differences in the site and the genetics, can all influence what the future of a tree. So the future of it being a dominant species or a suppressed species. So again, even age stand, what can we tell about it? Well, we can tell that the crown class, so our crown class, indicates relative rates of development. So a tree that is a dominant tree probably was either on a better site, lower density, or there is something that allowed it to become dominant. It has higher height growth, greater diameter, fuller crown. So there's something about this tree that says that makes it dominant. There was some kind of aspect that allowed it to increase in growth, increase in height, compared to, say, this tree over here. So this can also tell us a lot about our future tree vigor and growth. So, which to thin? How do we actually make that decision? Well, thinning, one way, we often think of removing less desirable species and also reducing inter-tree competition. And these less desirable species is really going to come down to what your goals, what your objectives are. So we're going to go through a few different ways to remove less desirable species, or less desirable trees. So when can you thin? You can thin at almost any age, and generally you want it to be commercially viable. A pre-commercial thin, or a PCT, is a thinning that yields inadequate. The yield is inadequate for commercial harvesting, or where the cutting removes only small diameter trees. So basically, you're paying to cut these trees out. These trees that you're removing are not making you money. So it's pre-commercial. So why do you want to thin? So there's many reasons. We can enhance wood production, control plants and animal habitat, improve resistance to insects and fire. And it's not just about what you're taking out. It's all about what you're leaving behind. And that's really key when we talk about not only thinning and tending, but also when we talk about regeneration mechanisms. So when we get into different silvicultural systems, we're always thinking about what we're leaving behind. And it's not just the number. We're also thinking about the quality, the spatial distribution. So the yield may be important, so that dollar sign may be important, and that money may allow you to do this work, but your focus should always be on the remaining stand. So silviculture is always focused on what's remaining, so making sure that this is sustainable, that this is good, that we are improving the stand. So we're going to go through these types of thinning. So there's low or thinning from below, crown or thinning from above, selection or diameter limit thinning, mechanical or geometric thinning, and a free thinning. So low thinning. So some other names include German thinning and thinning from below. And what a low thinning is, it removes trees of lower crown position, leaving the larger and more free to grow trees more or less evenly spaced over the area. So this is this is one of the most common ways we thin stands. So this is commonly used in ponderosa pine, in red pine. It's used in a lot of different situations. And it removes overtop trees and those in subordinate canopy positions and creates few gaps in the main crown canopy, except when applied at high intensity. So basically, you're taking out some of those lower quality trees. So when we talk about less desirable trees in this low thinning example are trees that may be suppressed, that may be intermediate. So these trees with subordinate crown position. So low thinning mimics natural mortality. So why does it mimic this natural mortality? So you're basically cutting smaller trees that are suppressed and would die first. So you're removing the trees that have the most likelihood of dying. So they're suppressed, they have small crowns, they have small diameters, they're not getting enough light. So you're removing those trees. So basically you're capturing this mortality. And you're focusing on growth in trees with the greatest promise to maximize growth rate. And so there are many benefits of this type of thinning, but it does remove vertical structure. And it keeps all that live foliage in one stratum and makes the stand look more park-like. So here's an example of a 44-year-old red pine plantation ready for a third thinning. So this example is from Bell Timber, and Bell makes poles. So they make telephone poles and other poles. So their goal is really focusing on quality of these poles. So they have a very specific way that they manage red pine for this resource. And as you can see, this is before a thinning, and really their goal is to create good quality trees for poles. So again, here's an example of a low thinning. So throughout this lecture, we're going to walk through these different thinnings. And right now, I want you to take out which trees, if you're doing a low thinning in this stand, what trees might you take out? So again, low thinning, we're taking out those suppressed or lower quality trees. So something like this may be what you have been thinking. So taking out trees that are suppressed, and hopefully focusing our growing space on these dominant and vigorous trees. So low thinning, one type of thinning. Another type of thinning includes crown thinning, or thinning from above. Thinning from above, the French method, or high thinning. And this reduces crowding within the main canopy and increases the light around the foliage of the residual tree. So Potlatch is one company in Minnesota that uses crown thinnings, and they usually use crown thinnings on their first thinning, because we'll talk about this in a second, but it allows the thinning to be profitable. It allows it to be commercially viable. And also, thinning in a red pine stand at this age, so they're generally not completely differentiated yet, so they haven't gone from codominant to dominant. They're all about the same size. So taking out these main canopy trees doesn't really, at least that's the idea, it wouldn't impact it. So we're still waiting on some more studies to come out about how the growth response is, and if this type of thinning does give that expected growth response. So, like I was saying, it removes some of the codominant and dominant trees to favor the best of those classes. So, and remove some dominant of undesirable characteristics, including trees of non-commercial or low-value species. And it leaves overtopped or intermediate trees that do not interfere with those better canopy positions. And it favors the most promising trees of upper canopy position, but not necessarily the dominant, by removing varied proportions of those in the stem. So you're focusing on the trees that you think will do the best, and these don't have to be the dominants. They can be co-dominant. So by removing a dominant or two or a few in that stratum, you're releasing these other codominants to allow greater growth in the future. And you're again focusing on high vigor trees, and you're ignoring those trees that don't impact it. So these smaller trees, these smaller diameter trees, they can serve as a trainer. And what trainers are they shade lower branches of crop trees. This promotes earlier branch mortality and earlier branch shedding along the lower bole. So basically you're trying to increase the quality of your wood. You use these trainers to increase the quality of your wood. It also can promote some heterogeneity in structural conditions. So a crown thinning. So again, we're thinning within the dominant and codominant layer. And any tree that is not interfering with a dominant or a codominant can be left and served as a trainer. So what do you think? Which trees would you take out? So maybe you took out a few of these. So again, we're focusing our growth on some codominant. So maybe by removing this tree, we're releasing these two trees to favor them, and we'll use this one as a trainer as it becomes more suppressed. And we'll release this one, and that will increase growth, increase vigor. And we're not really worried about these smaller trees because, again, they're going to serve as trainers. They're not impacting our overstory, our main story. So a selection thinning. Other names include thinning of the dominants, and characteristics include removing trees larger than a prescribed diameter limit to favor smaller trees of good growth, form, and condition. This method deliberately removes the most vigorous and largest trees from the stand. Why might you do this? So with this method, you're walking a very, very fine line. And you can do this if those less desirable trees, so you're thinning, we're removing less desirable trees. If those dominant, those most vigorous trees are of low value or have poor stem quality. This will increase light, you're increasing in the shrubs, the herbs, and the grasses, and good for certain wildlife species. This very fine line you're walking can turn into high grading. And high grading is the removal of the most commercially valuable trees, often leaving a residual stand composed of trees of poor conditions or species composition. This may have long-term genetic implications, economics, and stand health. And high grading is not silviculture. High grading, you're focusing on what you're removing. With silviculture, we're always focusing on what you're leaving behind. So selection thinning. Again, we're thinning the dominance. This is probably not the best picture to give this, that this wouldn't look like a high grading, but let's say if we can imagine maybe our dominant trees are less desirable species. So we don't like the dominant species and we want to remove it. So what might we do? So yeah, we're taking out those biggest trees, those most vigorous trees, with the idea that what we're releasing is more desirable than what we're taking out. Again, a very fine line you're walking. Mechanical thinning. Other names include geometric thinning. And this is exactly what it sounds like. You're thinning in some kind of spacing or spatial arrangement. So you're using some kind of spacing or spatial arrangement to identify the trees to cut or leave. Remove trees within a fixed spacing interval or by rows or by strips with fixed distances between them. Spacing thinning generally occurs in a natural stand. So a natural stand, you have this regeneration. It came in sporadic, like randomly, so it's not in these nice rows. So you can do this space thinning to kind of set yourself up for the future, to get it a little more manageable to work with in the future. Whereas a row thinning, that's what you look at when it's in a plantation. The spacing's already set up. You're just selecting which rows. You're selecting the spacing or the spatial arrangement. So, mechanical thinning is usually a first thinning, and this gets the space set for the next thinning. You're removing different size classes. So you're basically just saying every third row, or I want a spacing of 4 by 4. So in general, it's not going to alter the average diameter. You're taking out trees, whether they're dominant, suppressed, or whatever. If they're in that row or in that spacing, you're taking them out. And so there's also not a huge change in the vertical structure of the stand. You're kind of taking trees across all size and all diameter classes. And since this is usually a first thinning, there isn't a big difference between what's a dominant tree and what's a codominant tree and what's a suppressed tree. This is usually done very early in the stand. So, for example, if I was going to say we're going to use a mechanical thinning and thin every third row, what could it look like? So if we assume that we're looking into it, we would just thin every third tree and take out the tree, whether it's the dominant tree or whether it's a suppressed tree. So we're just thinning along that row. The last type of thinning is called free thinning. We use this thinning especially when selecting for crop trees. It can be also called a crop thinning. And some characteristics include favoring only the crop trees and leaving the remainder of the stand unthinned. So basically you have some kind of goals, you have this goal of maintaining or increasing quality in such and such a species. You can use a free thinning to really focus on those species. And this, you can favor desired species using a combination of thinning criteria. So you can use a combination of maybe a low thinning combined with thinning from above combined with thinning from below. So this free thinning just gives you this flexibility to really focus in on those crop trees, those trees that you're interested in. So it may combine elements of 2 or more thinning methods to adequately free designated crop trees for better growth. So an example includes growing black walnuts, and this is from the Minnesota Extension, and we can see it kind of takes into a lot of things. So we don't like the species. Maybe this one's a little crowded, but it's still a dominant tree. This one has a low fork. That one's crooked. So it's using these multiple criteria to really focus your growth on the trees that you're interested in. So selecting a thinning method. You're choosing which one to thin really comes back to this idea of what your goals and objectives are of the landowner, of yourself. Where is the stand going? And then we have to start looking at stand quality. So what are the diameter of the trees present, their quality, the arrangement or spacing of the potential crop trees, what's the composition, and what's the end use? What's the end product for the stand? Is it poles? Is it wildlife? Is it pulp? These are all going to influence how you thin and what intensity of thinning you do. So what does thinning do? We talked a little bit about this in a previous lecture, but give me 2 or 3 things that thinning does. So thinning, it can shorten the time for an individual tree to reach some specified diameter and favors trees with the best growth potential, improves the quality and value by focusing the growth on the most valuable trees and the most valuable species, increases product yield by harvesting trees that would otherwise succumb to intense intertree competition. Thinning captures this mortality, provides periodic revenues during intermediate stages of stand development, strengthens the boles and branches of residual trees, maintains tree vigor and removes trees susceptible to local insects and diseases, and maintains good phenotypes as a seed source for the next rotation. So these are just a little bit of a list of what thinning does. And I think as we've talked about in this lecture and previous lectures, we've touched on a lot of these things, but here's the list of actually what's happening, what it does. So this is a wrap up for this lecture. I'll see you guys in class.